Welcome. So we're on part 2 for 311, and we're looking at a scenario with 48 inches squared of paint and a rectangle with that is 8 inches longer than it is wide, so x and x plus 8. So you could write that inequality as x times x plus 8, that's the length, must be less than 48. You can build a table trying values of x starting at 0, which you can't do, but 0 times 8 is 0, and we notice at 4 you get 4 times 12, which is 48, and that's what we're comparing. So it's got to be less than 4. So we could say 1 and 9, and we could say 2 and 10. We could say 3 and 11. All three of those are going to result, if you look at this, they're all going to result in values that are less than 48, but still positive because it has to be as a rectangle. So what are the solutions to this inequality? One way you could do that, if you weren't using the table, is you could solve it algebraically. We could write this as x plus 48, x plus 8, and then we're going to subtract 48 and set it equal to 0 and just see where those points are. We think they might be at 4, but and then we can go ahead and solve that. So on this one, we've got x squared plus 8x minus 48 equals 0 as a quadratic to solve. If we solve this, we could do it in factored form. And negative 48 has to add up to plus 8. So 4 and 12 are the first things that come to mind. So if we say plus 12 minus 4, we get 8. So one possible solution here is x equals negative 12. Another one is x equals 4. You can see in the table that is the solution where it hits 48. This is not possible because you can't have a negative value. So the solutions, looking up here, the solutions are, let me erase this, the solutions are going to be where x, it has to be greater than 0, and it has to be less than 4, and that's because at 4 it's equal to 48. Now, how might your answer, you support it with a graph or table? Well, if we're looking at this thing right here, and let's say we're looking at 48. This is y is equal to 48 here, okay? One of the things we can see is at 4, it is equal to 48, right? And this is actually a 9 here. So you can see it's going to actually drop as it approaches that. That's one way you could look at it. In all these dimensions of x, it's less than 48 for the area. Here's another one. Let's say you had two expressions, and you're saying one must be less than the other. So I quickly graphed. Here's our x squared minus 4, and then over here is our 4x plus 1. And graphically, when we look at this, when is the parabola lower or less than the linear? And it's this area right here, you can see there's a difference between the two where it's lower. So what we're trying to do is we're trying to come up with an not approximation, but an exact value of where these are in the domain on the x-axis. One way is to see where they're equal, right? That's where the two functions are equal. So let's try solving as an equation. X squared minus 4 equals 4x plus 1. If you subtract 4x and subtract 1 from both sides, then you've got 0, and you've got x squared minus 4x minus 5. Now from that, we can actually, we can't factor that, negative 5. Oh, actually we can. So it'll be x and x equal to 0. So if we do negative 5 and positive 1, then we see that negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. So from this, we know that one solution is at x equals 5. The other solution is at x equals negative 1. Okay, so this point right here is at negative 1, and this point up here is at 5. Okay, if we're looking at this. So we can say that the system is less than over the domain, and the domain is going to be, if it's less than or equal, then it includes it, so it's going to be from negative 1 to 5.